Welcome to Dependency Injection, one of the most practical and widely used patterns in modern software development. By the end of this video, you will be able to recognize it in a real code base, understand why it exists, write a minimal version yourself, and know exactly when to reach for it and when to leave it alone. Imagine you have an order service, and inside its constructor you write new database repository and new email service. It works, but now your class is locked to those exact implementations. Want to test order service in isolation? You cannot, because every test hits the real database. Want to swap to a different email provider? You have to open order service and change it. The class is doing two jobs: its own logic and the job of deciding which tools to use. Think of a professional chef. The chef does not leave the kitchen to grow tomatoes or raise chickens. A supplier delivers the ingredients. The chef's only job is to cook. Your classes should work the same way. Declare what you need and let something outside hand those things to you. That outside supplier is the injector, and the ingredients are your dependencies. The pattern has four named participants. The client is any class that needs help to do its job. The service is whatever it needs: a database, a logger, an API client. Crucially, the client only knows the service through an interface, not the concrete type. And the injector, sometimes called a container or assembler, is the code that actually builds the service and hands it to the client. The most common form is constructor injection, where the service arrives as a constructor parameter. Let's walk through this top to bottom. First, we define a logger interface. This is the contract. Order service will only ever see this shape, never a concrete class. Then we write two implementations: console logger and file logger. Both satisfy the interface. Now look at order service. Its constructor accepts a logger parameter and stores it as a private field. There is no new keyword inside this class at all. Finally, at the bottom, the injector, here just our application entry point, creates a console logger, passes it into order services constructor, and that's the injection. To switch to file logger, we change exactly one line in the injector and nothing else. The key consequence of this pattern is called inversion of control. Normally, a class controls which tools it uses by constructing them itself. Dependency injection inverts that. An outside authority decides and delivers. Because the client only references an interface, you can substitute any conforming implementation: a production database in production, a fast in-memory stub in tests. At large scale, frameworks like Angular, Nest.js, or Spring handle the injector role automatically, resolving and wiring entire object graphs for you. Reach for dependency injection whenever testability matters, whenever you have or anticipate multiple implementations, or whenever a class touches cross-cutting concerns like logging or authentication. Skip it when the overhead outweighs the benefit. A 10-line script does not need a DI container. Also, watch out for the anti-pattern, where constructor injection is technically present, but the constructor takes 8 parameters, which usually signals the class itself needs to be broken up. To summarize, dependency injection is the practice of supplying a class's dependencies from the outside rather than letting it construct them itself. You code the client against an interface, let an injector handle the wiring, and gain the ability to swap implementations freely, including fast test doubles in your unit tests. Constructor injection is the most common and explicit form, and when your object graph grows large, a DI container automates the whole process for you.